Hello, this is day 15 of our daily push-up challenge while solving a Putnam problem. This time, this will be again from 1939, again an old Putnam competition. Just a fun fact, Putnam actually started from in 1938. So this is actually year 2, 1939. Okay, so let's insert some push-up first, a one set. 1, 2, 3, 4, 5. Okay, and we write it here. Okay, so the question reads, from the vertex 0c of the catenary y equals c cosh x over c, a line L is drawn perpendicular to the tangent to the catenary at a point P. Prove that the length of L intercepted by the axis is equal to the ordinate y of the point P. Okay, so if you've taken like a subject in physics, in particular mechanics, you know that a catenary is like the shape formed by like a chain or a cable sagging under its own weight. So if you hold it like a 2 points, a chain, and then it will sag under its own weight, that particular curve is called a catenary. Okay, but let's proceed with the push-up and think about how to proceed with this. 6, 7, 8, 9, 10. Okay, so we have 10, right? So let's draw it first so that we'll have like an idea what's going on here. So you have a point 0, x is 0, and then this is c. Okay, so this is point 0 c, and I don't know, maybe a catenary would look something like that. Okay, let me change that. That looks stupid. So something like that, I don't know. All right, but so the thing is, we're gonna pick a point P. So I don't know, maybe this point right here, for example. Okay, so this is point P, and it will have a coordinate. So let's call this point, I don't know, x sub 1. So it will have a coordinate x sub 1, and then y evaluated at x sub 1, which is c cosh x sub 1 over c. Okay, and then we take the line tangent to that point. So let me change the color of my ink here. So this line is tangent to the point P. Okay, and then what we do next is we draw a line through the vertex 0c, and then perpendicular to the tangent, so perpendicular to this blue line, so something like this. Okay, I don't know, does it look perpendicular to you? But yeah, you want this to be perpendicular, and then we get its intersection on the x-axis. Okay, and then now we would like to take this length. Okay, we call this L, and then we show that that length is actually equal to the ordinate y, so the y position of P, which is this one. Okay, so we want to show that that is equal. So one way to proceed here would be so we know the function of the curve. So at a particular point, we take its derivative, we evaluate it at that point, it gives us the slope of the blue line. From the slope of the blue line, we can obtain the slope of the green line, and then from the slope of the green line and the fact that it is intersecting the vertex, we can obtain the equation of the green line. And then from there, we should be able to study, to look at its length, because now we know its equation. We will be able to pick 2 points, the one where it intersects the x-axis and the point where it intersects the y-axis, which is given, which is 0c. Okay, let's continue the push-up. 11, 12, 13, 14, 15. 15. And it's red, but it's fine. Okay, so we're now at 15. So what did I say? I said we take the derivative of the curve, and then we evaluated it at x equals x1. I don't know why my iPad is flickering like that, or the app. But anyway, so the function is just c cosh x over c. So the derivative is, so you take the constant c, and then the coefficient is 1 over c, and this becomes hyperbolic sine or sinh with an h x over c evaluated at x sub 1. So this is x sub 1. Okay, therefore that is just sinh x sub 1 over c. Let's write that carefully, because over c is inside is a parameter of the hyperbolic sine. Okay, so now we know the curve. This is the let's label this. This is the slope of the tangent. Okay, so the slope of the tangent, let's go to a tangent. Let's go to like a side discussion here. So if the slope of the tangent, okay, which we know is equal to sinh of x1 over c, we can call it m, right? That is also equal to the tangent of the inclination of that blue line with respect to the x-axis, like we've mentioned from the video yesterday. Okay, and if you look carefully at the green line, so the slope, the green line is L. Okay, so let's call this is L. Okay, the green line. The slope of L is actually equal to the tangent theta plus 90 degrees, because now if you look at the inclination of the green line with respect to the x-axis, let's draw it here. Let's look at this figure. This particular angle right here I'm drawing right now, that's actually just theta plus 90 degrees. If you study it carefully, theta being the angle of the blue line, okay, with the x-axis. All right, so now what do? We can actually apply the summation formula for tangent. Okay, so this is actually equal to what was it? Tan theta plus tan 90 degrees over 1 minus tan theta tan 90 degrees. But we have to be careful here because tan of 90 degrees is actually infinite, you know, it's divergent. So what we can do is we can divide the whole thing by 90 degrees per term, so that when we take the tan of 90, infinity, it will be in the denominator. So anything it's divided, it's dividing, anything that it is dividing will be approaching 0. Okay, so this is 1 over tan 90 degrees minus so that is the tan 90 will cancel this. This is just tan theta. Okay, so this is equal to, so since tan 90 degrees is infinity, this is equal to 1 over negative tan theta, or just equal to negative 1 over m. Okay, and this actually like the equation you're given in elementary, or was it high school? I believe it's elementary. I remember like learning this thing in grade 6, where they tell you that if you have a line with a slope m, the line perpendicular to that line with the slope m is negative 1 over m. Okay, this is actually where it comes from, right? From the addition formula of the tangent. But anyway, so since it is negative 1 over m, this is just negative 1 over sinh of x1 over c. So this negative 1 over sinh of x1 over c is the slope of line L, the green line in our figure. Okay, so now that we know the slope, okay, so line L has slope, let me write the slope there carefully, has slope negative 1 over sinh x1 over c, and passes through 0c. Okay, that's given. So we're given a point, and then we know the slope, then we can get the equation of the line. We just use the point slope form of the equation. But anyway, let's continue our push up. We're now at 15, 16, 17, 18, 19, 20. Okay, so 20. Okay, so now let's write the equation of the green line, okay, the line L. So that's just given by y minus its y position, in this case c, equals the slope m. So this is or in this case m sub 2m of the green line. So this is negative 1 over sinh x1 over c multiplied by x minus the x point we're given, in this case 0. Okay, so the equation of the line is just, the green line is just y equals negative 1 over sinh x1 c x plus c. Okay, that's the equation of your green line. This implies, okay, we know that it passes through the y-axis via 0c. The problem wants us to calculate the length between its interception with the two axes, right? So we already know the interception with the y-axis 0c. We now want to get the interception with the x-axis. That's just simple. Since we already know the equation of the line, we just set y equals 0. Okay, so if y equals 0 in here, this implies that x is equal to, okay, if y is equal to 0, let's write this as x-intercept. so that we know that this particular x is important. So y x-intercept is when y is equal to 0, so that gives you c sinh x1 over c. Okay, correct? So now we know 2 points. Okay, line L intercepts the axis at so at x-axis it intercepts at line c sinh x1 over c 0, and then at the y-axis it intercepts at 0 c. Okay, therefore we are given the 2 points where it intercepts. We want to find the length of that, right? The red thing here. Okay, so now we just use the distance formula because we know the 2 points. So let's finish the push up first. We're now at 20, so this is the last set. 21, 22, 23, 24, 25. Okay, so distance formula. So now the length of L between the where it intercepts the two axes is given by so the point x c sine x1 over c minus 0 squared plus the point y 0 minus c squared, and then you take the square root. This just gives you square root of c squared sinh squared x1 over c plus c squared. We can of course factor out c. Okay, square root of sinh squared x1 over c plus 1. But note that in the hyperbolic the hyperbolic expression or formula for the relationship between cosh and sinh, cosh squared minus sinh squared is equal to 1. Okay, therefore 1 plus sinh squared is exactly cosh squared. Okay, so therefore this is equal to c sinh squared x1 over c. So this is the length of the line, the green line, line L, passing through the y-axis and the intercepting the y-axis and the x-axis. But we are asked to prove that we are asked to show that the length of L is the y coordinate of point P. Well, the y coordinate of point P is given by this one, right? C cosh x1 over c, which is exactly sorry, I wrote sinh. I said this is cosh, okay? Because sinh squared plus 1 is equal to cosh squared. You take the square root, this should be cosh, okay? So I just messed up by writing it, but in my mind it should be cosh, okay? So, but anyway, yeah, the length of the line, which is c cosh squared x1c, is exactly equal to the what we have here, what we've set the ordinate of point P to be, okay? And so we're done. We were able to show it. But anyway, yeah, this is has been a not really very long, but very detailed discussion I gave. But anyway, this is push up number day number 15, right? And then we have 10 more days to go. I'll see you next time. Thanks for watching, guys, and bye bye.